This video is going to go over logarithmic functions. To show how this relates to exponents, say if you have the exponential equation y equals a raised to a power of x. To rewrite this as a logarithm, you would have log base a, whatever the number a is, of your y value is equal to x. Log base a, the bases are the same, both logarithm and exponent. Log base a of your output value is always equal to your exponent. So for example, if I was to give you log base x of 8/27 is equal to 3, and I would tell you to solve for x. You can start by rewriting this as an exponent. Remember, the bases are the same in both the exponent and the logarithm, so your base of your exponent would be the same as your base for your logarithm, which is x. Remember, the exponent for your exponential function is the same as the output of your logarithm, so it would be x to the third equals the input of your logarithm, which would be 8/27. Now to solve for x, since it's raised to the third power, you would do the cubed root. Cubed root of x to the third is just x, equals cubed root of 8, which is 2, over the cubed root of 27, which is 3. So it's value of, so the base of our logarithm would be 2/3. Alright, so suppose I ask you to solve log base 4 of x equals 5/2. Let's rewrite that as an exponential. The base of our exponent would be the same as the base of our logarithm, so it would be 4. Remember, whatever our output is for our logarithm, that's our exponent, so 4 raised to the 5/2 is equal to the input of our logarithm, which is x. So if it's 4 raised to the 5/2, since you have 2 on the bottom, that's like taking the square root of 4 to the 5th is equal to x. And correct me if I'm wrong next time I'm in class, but that should be square root of 1024 equals x. Which means x should be, I believe, should be 32. Normally whenever you take the square root of a number, you would do the positive or negative, but there's something you need to know about logarithms, and that is that for any logarithm log base b of x, the input value x cannot be negative. Now let's discuss how to graph these logarithmic functions. But before we do that, let's discuss some basic details. For the general logarithmic function log base b of x, the domain, remember the domain cannot be negative, so it'd be all the values greater than 0. And the range, it's just all real numbers. This goes from negative infinity to positive infinity. And when your base is greater than 0, the graph will look something like this. So if you had something in general like log base 2 of x, for example, the graph will look something like the blue graph there. And say if you have a base that's a fraction, like say log base 1/2 of x, for example, then the graph will look in general something like this. Now that we've discussed in general what the graphs will look like, let's go over how to graph them. Alright, for this example, I know it says graph both these functions, log base 1/2 of x and log base 3 of x. But I'm only going to do one of them because the process is the same for both. So for part A, you would do, I think the easiest way would be to start by just graphing 1/2 raised to the power of x. Not graph it, but plot the points. Like when x is -1, y is 2. When x is 0, y is 1. When x is 1, y is 1/2. Now for log base 1/2 of x, you just flip the x and the y. So when x is 2, y is -1. When x is 1, y is 0. And when x is 1/2, y is 1. Just remember, domains and exponential functions are inverses of each other, so the domains and ranges flip. So now if you plot this point, these 3 points right here, 2, -1, 1, 0, and 1/2, 1, then your graph should look something like, it'll look something like this, like the blue graph. If you look, it contains the point 2, -1, the point 1, 0, and the point 1/2, 1. Just like we said on our table on the last slide. Now you do part B the same way. Just rewrite log base 3 of x as an exponent. And for log base 3 of x equals y, you do write as an exponent. Figure out what values of the exponent, or better yet, a better way to do it would just start by just graphing the exponential, 3 raised to the power of x. So when x is 0, y is 1. When x is 1, y is 3. When x is 2, y is 9. And then just flip those coordinates for the points on the logarithmic function. So like the logarithmic function would have the point 1, 0, the point 3, 1, and the point 9, 2. So now let's go over some properties of logarithms. Alright. Number 1, if you have 2 logarithms, if you have an input of 2 things being multiplied inside the logarithm, you can split them to separate logarithms and add them. Now the second property is that when you're dividing 2 things inside a logarithm, you can split them to separate logarithms and then subtract. Now whenever you have the input raised to an exponent, what you can do is just move that exponent to the front of the logarithm. So it'd be p times log base b of whatever your input is. And whenever you have log base whatever of 1, that's always equal to 0. Because remember, you can always rewrite that as an exponent, because you have the base raised to a power of whatever the output is, which is 0, is equal to 1. Alright, so for this example it says rewrite each expression. So you see how it's each thing is in a single logarithm? We're going to split it into separate logarithms. So like for part A, log base 6 of 7 times 9. Since we're multiplying, we can split them into separate logarithms. Log base 6 of 7, and then log base 6 of 9. And then we would add them. And that's how you would do it. Log base, or for part B, log base 9 of 15 over 7. Since we're dividing, we can split them into separate logarithms. 15 and 7. Since we're dividing, we would subtract them. And that's how you do it. And for part C, log base 5 is square root of 8. Thus, this you can rewrite that as log base 5 of, since it's square root of 8, that's like having 8 to the 1/2 power, which you can then rewrite as 1/2. Move the exponent to the front, so it's 1/2 times log base 5 of 8. Now for part D, you have log base b of this rational expression m times n times q divided by p squared times t to the 4th. Alright, since we have the fraction, we can start off by subtracting them, like split them into separate logarithms. And then subtract. Alright, and then we have log base b of m and q, so that's equal to log base b of, since we're multiplying m, n, and q together, we can split those into separate logarithms and then add them. Then subtract, since we're multiplying p squared and t to the 4th, we can split those into separate logarithms and add them. Log base b of p squared plus log base b of t to the 4th. Now you see how we have these two exponents? Well, if we write the first part, log base b of m plus log base b of n plus log base b of q, we need to move these exponents to the front of the respective logarithm, so it'd be minus, open parentheses, log base b, wait, you need to move the 2 in front, so it'd be 2 log base b of p, plus, move this 4 in front here, so it'd be plus 4 log base b of t. Now, since we have these parentheses, since we're subtracting this parentheses, why don't we just distribute this minus into the logarithms? So that'd be equal to, if we write this down, write the first part down, log base b of m plus log base b of n plus log base b of q. Then since we distributed the minus, that'd be minus 2 log base b of p plus, actually not plus, it'd be minus 4 log base b of t. And that would be our answer. In part E, I believe it said log base a of the cubed root of m squared. Let's get rid of the radical. Because remember, the cubed root of something is the same as raising that to the 1/3 power. Remember, whenever we have a power to another power, we just multiply the exponent, so it would be log base a of 2 times 1/3 would be 2/3. Bring the 2/3 in front, so it would be 2/3 times log base a of m. Alright, for this example, I want you to write each of these as a single logarithm. Now, For part A, since we're adding the first two, we would multiply the first two together, so it'd be log base 3 of x times x plus 2. Now, since we're subtracting the third logarithm, we would just divide that part by 2. So that's how you do it. Alright, so for part B, it says, once you combine this to a single logarithm, 2 log base a of m minus 3 log base a of n. Now, in order to combine them to a single logarithm, you need to get rid of the numbers in front first. To get rid of the 2, you could rewrite it as an exponent. So it'd be log base a of m squared minus, move the 3 to the exponent at the end, so it'd be minus log base a of n to the third. Now, since you have no coefficients in front of the logarithms, you can combine them into a single log. Since we're subtracting, we would divide, so it'd be log, let me rewrite that, log base a of m squared over n to the third.